my name is Sophia.
Hi, my name is Mehdi.
Hi, my name is Lucas.
Hi, my name is Haneesh.
And we're Team 5 of the SAR program.
Synthetic aperture radar, also known as SAR, is a method of radar imaging that overlays multiple scans of a set area to construct images. SAR is able to avoid aperture constraints of the traditional radar system by using scans from multiple positions of a set area. This technology is able to be operated in many different situations that would prohibit orthodox camera photography, such as clouds, rain, and low light. Currently, SAR is being utilized for military, ecological, and astronomical purposes, but has the potential to be utilized in many different fields as the technology develops. The backend of our program is handled by a main script that calls on the methods which communicate with the radar emulator. These methods send byte strings distinguished with IDs to communicate the method type and receive byte strings back from the emulator. The sequence of communication is as follows. First, the emulator sends a communication check request, which initiates and checks connection with the radar. The radar passes back the values it received, and the client is able to cross-reference these values to make sure there was a successful connection. Next, the client sends the radar configurations. These are the settings that dictate how the radar will run its scans by determining values such as start and stop time and the resolution of the scans. The values are sent back from the radar for the client to check. Finally, the client sends the messages to activate the radar, and the radar begins sending the client data as it collects. This data comes in packets that are accompanied by their IDs and configurations which the client parses. The parsed data is packaged into a pickle file and sent to the backprojection to be processed into images.
This is our graphical user interface, otherwise known as a GUI, and this is where we control the configurations sent to the radar.
Backprojection computationally forms a SAR image using data received from the radar. We took two perspectives when tackling this. The first, called moving radar, is slower but more reliable. We use it to image larger areas with lower resolution. Moving radar does this by filling in an image pixel by pixel with values computed from radar data. To optimize this, we use linear interpolation, which estimates unknown values from known values. The user inputs image dimension, pixel dimension, and center point coordinates. Adjusting image dimension allows us to zoom in and out. Changing pixel dimension adjusts the image resolution, and specifying the center point coordinates allows us to search for a target within an area.
In addition to moving radar, we also constructed a different form of backprojection called stationary radar. Stationary radar addresses the problem of calculating the distance between the radar and every given pixel position taking too long. It does this by calculating all the possible ranges ahead of time and then shifting our snapshot of the possible ranges as the plane flies. So instead of calculating the green square all by itself, we take most of the information that we got from the red square and use most of it in the green square and just calculate the little lip of the non-overlapping part of the red and green square, drastically reducing the computing time of the range.
As a side project, we worked on determining the number of vehicles and the coordinates of their centers within a given backprojected SAR image. Here is the result.
I think we all develop the skills to work with other people, to listen to others, and most importantly, trust each other when one of us has a good idea. BWSI has been a great experience because of our instructor Ramu, who structured the course to provide a very similar experience to that of the real world, allowing for some serious practice with problem solving.
At the beginning, working on a month-long project on a team filled with people I didn't know felt like an impossible task. But as we got to know each other, not only did the days seem shorter, but the project was a lot more fun. There were a lot of differences between working with a commercial device and your own code. Mainly, we had to rely on provided documentation to figure out the radar's requirements, as we didn't have access to the source code. We split up into two groups to work on each system, and in the last week, we came together to integrate these two systems. This was one of the most difficult parts of our project, and we learned a lot about communicating about a code effectively and using different methods to get the right images. In summary, we learned a lot about SAR and using a radar, even though we could only use an emulator. In the end, we faced many challenges, but we also had many successes. I believe we each learned a lot from these experiences and will definitely use these lessons we learned this month in the future. Thank you.